Okay, this is the extension question at the end of the topic test. So I can do 3 decimal places, you beauty. I can work in graphing mode. Find the intersection point between this and this. Okay, so I've got negative e to the minus 2x, and then outside of that plus 1. And I've got x. So edit, clear all. And what am I finding? Intersection point. Analysis, G solve intersection, 0, 0, beautiful. And moving across 0.7968, so 797, 797. Write a definite integral that represents this area. That's a definite integral that represents that area. And if I go analysis, G solve integral intersection, I'll accept the first one, XE, come across to the second one, XE, there is the area, 0.0809, so 0.081. Okay, part C changes the function to S of X, where I've got a C here. Now this C is where the negative 2 was. And I need to consider when C is equal to negative 5, negative 10, negative 30. Okay, so I'm exploring what happens when the value which was the power on the E is negative 2, negative 5, negative 10, negative 30. Okay, so I'm going to go negative 5. I'm going to graph this. And I want the intersection between green and red. So analysis, G solve integral intersection. I want red, so XE, green, XE, XE for that intersection point. Move to the right for the second intersection point, and that is 0.301 or negative 5. Yep, 0.30. I've written the answer from this one up here, down here by mistake. Okay, so now I'm going to consider negative 10. So I'm wanting pink and red. Analysis, G solve, integral, intersection. I'll have that one. No, I picked the wrong one, so let's clear that. Analysis, G solve, integral, intersection. I don't want that one. I do want that one, so yes. And that's the top one I want. And I'll accept that one, and I go across and accept that one, and I get an area of 0.4. And I could do the same thing in a minute and do negative 30 and get 0.6467 the same way. Okay, so now state the upper limit of the enclosed area between S of X and N of X, i.e. the enclosed area as C approaches negative infinity. So I've done C equals negative 2, negative 5, negative 10, negative 30, and I've gone from 0.08, 0.3, 0.4, 0.467. What happens if I make C equal to minus infinity? Well, I can't do minus infinity, but I could do minus 100 and see what happens. And notice that my curve is getting closer and closer and closer to the y-axis and to the asymptote. And I want black and red. So there's my red one. There's my black one. And there's the first intersection point, and there's the second. and I got 0.49. So when C equaled negative 100, area equals 0.49, I'm saying that the smaller it goes, it's going to approach a half. And where do I get that from? This curve is getting closer and closer and closer to fill the triangle bound by the asymptote, the y-axis, and the line y equals x, and that area equals a half. So the upper limit of the area is going to equal the area of the triangle, a half. And looking at part E, state the upper limit of the enclosed area between the function s and its inverse. Well, if I was to edit clear all OK, and I was to say that that was negative 10, and I drag and drop that, and I zoom in on that area, and analysis sketch its inverse, you'll notice that the inverse is below here. So in actual fact, this is my inverse, and this is the function. And as C gets smaller and smaller and smaller and smaller, these curves are going to hug the y-axis and the asymptote and the x-axis, and this area is going to approach the rectangle, which is 1 unit across and 1 unit down, or the area is going to approach 1.